Define programming. Describe the various levels of programming languages. State the advantages and disadvantages of each level of the programming language. Define the terms assembler, compiler, interpreter, source program, and object program. Describe the stages of program development. Describe the program control structures. And define and develop algorithm, pseudocode, and flowchart. In Form 2, we discussed about application packages such as word processors, spreadsheets, databases, and desktop publishers. These are off-shelf application software. We also have in-house developed software that are developed to suit user-specific needs. All these are computer programs. These programs are developed by computer programmers using a variety Introduction to Computer Programming. By the end of this lesson, the learner should be able to define the term computer program, define the term computer programming, and explain programming language.
Computer program. It is a setup of step-by-step instructions that a computer uses to perform a task. Computer programming. It is the process of writing computer programs. Programming language. This is a predefined set of symbols used to write computer instructions.
Description of terms used in programming.
Source code. These are the instructions written in a particular programming language. Object code. This is the source code that has been converted to machine-readable form. Translators. A translator is a program that converts source code into object code. They are categorized as assemblers, interpreters, and compilers.
Assemblers are programs that translate programs written in assembly language into machine language. Interpreters are programs that translate the source program line by line, allowing the CPU to execute one line before translating the next. Compilers are programs that translate the entire source program into object code. In the previous lesson, we discussed about computer programming and highlighted programming languages. For example, during booting process, a computer user will only notice different activities happening on the screen until he or she starts using the computer. The noticeable activities on the screen are the user interface. These activities occur when a series of codes are executed by the processor. The series of instructions executed are the source code and objective code, respectively. By the end of this lesson, the learner should be able to differentiate between source code and object code, explain language translators. Levels of programming languages.
Objectives. Describe levels of programming languages and state the advantages and disadvantages of each level of programming languages. Background knowledge. Programs used by earlier computers were written in languages that were easily understood by the computer directly. These languages are known as low-level languages. As technology advanced, languages that resembled human language were developed to make programming easy. These were known as high-level programming languages. Low-level languages. They are the programming languages that are easily understood by the computer because they require little or no translation into object code. These programming languages are categorized into two types: first-generation language, that is machine language, and second-generation language, that is assembly language. Machine language or first-generation language. This is a language where the instructions are written in binary code. Each statement in the binary program corresponds to one machine action. Assembly language or second-generation language. This is a language that is written using both shortened words, that is mnemonics, and binary codes. Assembly codes are translated into machine language using a program called assembler before they are executed. Example: ADD 1111 1001. This means that add the binary number 1111 to the binary number 1001. SUBR1 101. This means subtract 101 from the contents of the register R1 and store the result in the register R1. Print R1. This means print the contents of the register R1. Advantages and disadvantages of low-level languages. Advantages of low-level languages are: they are faster to execute because they need little or no translation, and they are stable in their execution. This is because they communicate to the hardware directly. Disadvantages of low-level languages are: they are very difficult to learn. This is because they are not close to the human language. They are difficult to code or write programs. Coding requires trained experts. It is difficult to debug programs created using these languages. This means it is difficult to correct errors. They are machine dependent, that is, they are not portable. This means that a program written for a particular hardware type cannot be used in another type of hardware. Advantages and disadvantages of high-level languages. Advantages of high-level languages are: they are user-friendly because they are nearer to the human language. They are easier to learn. They require less time to code. They are portable, that is, it is machine independent. They are easy to debug, and they are flexible, hence enhancing the creativity. High-level languages. These are programming languages that are closer to the human language. These programming languages are of four types: third-generation languages, 3GLs, fourth-level programming languages, 4GLs, object-oriented programming languages, OOP, and web scripting programming languages. Third-generation languages. These are languages that enable a program to be divided into manageable parts called modules or procedures. They are also referred to as procedural languages. Fourth-generation languages. These are languages that have ready-made tools for common programming tasks. The user builds a program by integrating these tools and their codes. These languages usually provide the user with an integrated development environment. Examples: SQL, Nomad, Visual Basic, Delphi, Pascal, and Visual C++. Object-oriented programming languages. These are languages that a programming task is viewed as an object. An object is viewed as an entity that has its own set of data and functions to achieve. Several related objects grouped together make a class, and several related classes make a program. The objects interact with each other by passing messages. Examples: Java, C++, Simula, and Smalltalk. Web scripting programming languages. These are languages that are used to develop dynamic web pages. They can also be used to add more functionality to a web page, thereby making it more interactive. Examples: HTML, PHP, JavaScript, ASP.NET, ASP, VBScript, and Joomla. Advantages and disadvantages of high-level languages. Advantages of high-level languages are: they are user-friendly because they are nearer to the human language, they are easier to learn, they require less time to code, they are portable, that is, it is machine-independent, they are easy to debug, and they are flexible, hence enhancing the creativity of the programmer. Disadvantages of high-level languages. They require large computer memory to run in, and the execution consumes time. This is because the program has to be interrupted or compiled to machine-readable form before the computer can execute it. Program development. Objectives. By the end of this lesson, the learner should be able to describe the stages of program development. Background. For a computer to run, it must be loaded with appropriate programs. These programs are developed by computer programmers who follow a series of stages to come up with the programs. In a bread manufacturing industry, bread is baked following a predefined set of stages.
Program is developed using the following stages: problem recognition, problem definition, program design, program coding, testing and debugging, and program implementation.
Stage 1. Problem recognition. In this stage, a problem is identified and its magnitude expressed. It is important to be very keen in this stage as each detail affects the next stages. The circumstances that can cause a programmer to identify a problem are: opportunity to improve the current system, a new directive by the management or government, and problems or undesirable situations that prevent an organization from achieving its purpose.
School examination processing system. In this case study, consider the problems faced by teachers when processing students' end-term reports. school examination processing system. In this case study, consider the problem.
Stage 2. Problem definition. This stage tasks the analyst to understand and interpret a particular problem. In this stage, the analyst sets the objectives of the new program and determines the scope or boundaries of the new program.
In this stage of our case study, let the students identify the necessary inputs, processes, and outputs in the school examination processing system. In this stage of our case study, let the students.
Stage 3. Program design. This is a stage where an analyst uses a suitable algorithm to depict a program's logic. An algorithm is a definite number of logical steps followed to solve a particular problem. Some of the tools used to design algorithms include flowcharts, pseudocode, entity relation diagrams, that is ERD, decision trees, data flow diagrams, that is DFD, and decision tables.
In this case study, consider the students developing the algorithm of school examination processing system.
Stage 4. Program coding. This is a stage where the programmer converts the program design into program source code using an appropriate programming language. Stage 5. Program testing and debugging. This involves going through the program so as to identify the correct errors. Program testing is running the program using test data so as to evaluate if the program generates the expected output. In case of unexpected output, the program is corrected, that is, debugged.
In this stage of our case study, the students go through the program so as to identify and correct errors. The students create test data so as to evaluate if the program generates the expected output.
Types of errors or bugs encountered during program testing. There are two common types of errors encountered during program testing, namely syntax errors and logical errors.
Syntax errors. These are errors that occur when the programmer uses improper language rules. They are detected during dry running or when translating the program.
Logical errors. These are errors that occur when the program gives wrong results. They are not detected by translators. Example, when a programmer entered plus instead of multiplication. The results would be summation instead of product. Solution. Go back to program code to read and identify the problem. Stage 5. Implementation. This is a stage where the computer programmer delivers the program to the client and then installs it in the computers. It also involves training the client on how to use the program.
In this stage of our case study, the students
installs and then trains the client on how to use the program.
In this stage of our case study, the students
installs and then trains the client on how to use the program.
Documentation. Program documentation involves writing support material about the program. Some of these support materials explain how the program can be used, how the program can be installed by operators, and other technical details about the program that can assist other programmers should they want to modify the program. It is very necessary to develop documentation for all stages involved in the program development. Note that documentation should be done at every stage. Definition and development of algorithms. By the end of this lesson, the learner should be able to state program development tools, develop an algorithm using a pseudocode, and develop an algorithm using a flowchart.
Background knowledge. In program development, we learned that the third stage is program design. In this stage, we mentioned the following two algorithm design tools, pseudocodes and flowcharts. Note that an algorithm is open-ended. It is therefore wise to encourage students to develop algorithms using a specific tool. Pseudocode. Pseudocode is defined as a set of statements written in a human-readable language to express the processing logic of a program. There are no set of rules for writing the pseudocode. When writing a pseudocode, you must use consistent language and syntax so that it can be properly understood by the programmer and any other person.
Flowcharts. A flowchart is a diagrammatic representation of a program's processing logic. It uses symbols and short statements that describe various activities. Program flowcharts are designed using various symbols that represent different operations. This flowchart shows the sequence of steps followed when opening a word processing package. This is a flowchart for a program that prompts the user to enter two numbers, calculates sum, average, and grade. The program should output the sum, average, and grade. Program control structures are a set of statements that determine how a program is executed. They are also defined as a set of statements in programming that allows the programmer to control the flow of the program. There are three program control structures, namely sequence, selection, and looping, which is also referred to as iteration. By the end of this lesson, the learner should be able to describe the program control structures. In the previous lesson, we learned about pseudocodes and flowcharts. The pseudocodes and flowcharts provide a simplified analysis of the program logic. In this lesson, we are going to discuss about program control structures. Sequence. In sequence control structure, the statements are executed one by one in consecutive order. It involves linear execution of statements in a program. The flowchart shown depicts a sample sequence of statements. Flowchart for a program illustrating a sequence. Selection. Selection control structure is used when the program is to make a decision based on a condition that is either true or false. For example, a programmer may write a program that assigns different grades for different scores. This can be best done with selection control structure. There are three types of selection control structures. These are if, then. This is used only when one option is available. If, then, else, and this is used when there are two available options. Nested if, and this is used when two or more options have to be considered to make a selection. And case selection. This is used as an alternative to the nested if, and it is mainly preferred in order to reduce the many lines Sample flowchart illustrating a selection control structure, if, then, else.
Iteration or looping. This is a program control structure that allows a program to repeatedly execute a set of statements until a certain condition is met. There are three categories of looping control structures, namely while, do, repeat, until, for, loop.
For example, a teacher entering students' end term marks in their report, he or she will continue entering the marks until all entries for each student are finished. For example, a teacher entering students' end term marks in their report, he or she will continue entering the marks until all entries for each student are finished.